Okay, exercise 7.9, question 1. So we just have a sketch here of the information that's given in the question. Just to add in, it tells that PR is 8 meters and so is RQ. So just to fill that out on the diagram that they've given. So the first thing we're asked to do is to find the distance between PQ. So we're going to take the triangle that's on the ground and use the cosine rule to do that. So for part 1, PQ, all to be squared, 8 squared, minus 2 times 8 times 8 times cos of 120. So just banging all that into the calculator, PQ squared is 192. So the length of PQ is 8 root 3, which is 13.85640,646, and they ask you to round it to the nearest meter, so that's approximately 14 meters. The next thing they want you to do is find the length of SR, this rope here. Now it doesn't look like it, but this triangle SPR is in fact a right angle triangle. What you need to picture in your head is like a goalpost in a pitch. The triangle that's created on the ground is a shadow. So the land is going to be perpendicular to this pole. So any shadow or any triangle that's formed in the bottom is going to be a right angle triangle. So taking that fact, part 2, just to sketch it out, we have SPR and we fill in the information that we have. So we're just working out the hypotenuse. So we just use Pythagoras' theorem. So SR squared equals 10 squared plus 8 squared. So SR squared is 164. So the length of SR is 2 root 41 meters. And they ask for it in surd form, so there's absolutely no need to change that at all. So the next thing we are asked to do is to find the angle SRT. So this little bit in here. The 120, remember, applies to the triangle that's on the ground if you're imagining a goalpost. Okay, the one we're looking for is the angle that's created between the two ropes connecting S to R and T to R. So we sketch that triangle down here. This is what we have, S, T and R. We're looking for this one here. We've just worked out that these measurements are 2 root 41. Now this is a gap in the actual setup, but this gap corresponds to this distance here, which we calculated earlier as being 14 meters. So that's the same up here because it's directly above it, like in a rectangle. So we have 14 meters here. So we can use the cosine rule to then figure out what we don't know. So we have 14 squared equals 2 root 41, all to be squared, 2 root 41, all to be squared, minus 2 times 2 root 41 by 2 root 41 times cos of angle SRT. So plug it into the calculator, tidy it all up, and you end up that cos of angle SRT is equal to 33 over 82. So getting inverse cos of this, angle SRT is equal to 66.26925752. And we round it to the nearest angle, or sorry, to the nearest degree, which is 66 degrees.